All right, let's jump right in. Today, we are talking about the top 5 use cases for one of the most important tools in all of modern tech, Apache Kafka. You might not know it, but this thing is the secret engine behind a ton of the real-time services you probably use every single day.
So, have you ever wondered how your bank can flag a weird transaction, like moments after you swipe your card? Or how a ride sharing app can track thousands of cars all at once in real time on a map? Well, the secret sauce involves handling this insane nonstop stream of data, these events. But how on earth do they pull it off?
Well, say hello to Apache Kafka. It's funny, it started out as this pretty simple tool for processing logs over at LinkedIn, but since then, man, it has evolved into this incredibly versatile, distributed event streaming platform. The best way to think of it, it's like a super fast, super reliable central nervous system for all of your data.
So, in this explainer, we're going to break down 5 of the most critical ways Kafka is being used out in the wild today. We'll start with how it tames that crazy flood of logs. Then we'll get into how it powers real-time AI and acts as a system watchtower. And after that, we'll look at its role as a universal data hub and, get this, how it can even make system migrations way less of a nightmare. Let's do this. So our first use case, this one takes us right back to Kafka's roots, log analysis. But these days, it's about so much more than just collecting text files. It's really about making sense of this chaotic, overwhelming flood of information coming from countless different sources, all at the exact same time. I mean, just think about it. Modern systems are so complex, right? You've got logs pouring in from hundreds, maybe thousands of microservices. You've got events from different cloud platforms, data from all your applications. Kafka's superpower is its ability to just drink all of this high-volume data in simultaneously while keeping the delay, the latency, incredibly low. We're talking milliseconds. It just doesn't get overwhelmed, it just handles the flood. But here's where Kafka becomes a true powerhouse, when you pair it with other tools. By integrating it with what's called the ELK stack, that stands for Elasticsearch, Logstash, and Kibana, engineers can build a dashboard that gives them a live, searchable, and visual look at the health of the entire system. Kafka is the pipeline that feeds all the data in, and the ELK stack is what makes it beautifully useful and easy to understand. Okay, let's move on to our second use case, which kind of builds on the first one. We're talking about powering the incredibly demanding world of modern machine learning. You see, AI models are they're hungry for data, and they need it fresh, and they need it fast. And Kafka is just the perfect tool for this job. It slots right in, acting as that central nervous system we talked about, but this time for machine learning pipelines. It just ingests this continuous stream of data. It could be user clicks, sensor readings from IoT devices, financial transactions, you name it. And then it reliably feeds all of that into ML models for real-time decision-making. And you can really see the impact in the real world. That instant alert you get from your bank about a suspicious purchase? Yeah, that's very likely Kafka streaming data into a fraud detection model in real time. Or that giant machine in a factory that gets serviced right before it's about to break down. That's Kafka, funneling sensor data to a predictive maintenance model. It's the thing that makes AI immediate and actually useful. Now, our third use case shifts our focus a little bit. We're moving away from investigating the past to watching what's happening right now. This is all about being proactive instead of reactive. It's about turning Kafka into the ultimate watchtower for your entire system's health. And right here, you can see the key difference. Log analysis, the first thing we talked about, that's reactive. It's all about digging through past events to figure out what went wrong after the fact. But system monitoring with Kafka, that's proactive. It's about tracking key metrics in real time, spotting weird anomalies as they happen, and triggering alerts right away, before a tiny little issue snowballs into a massive outage. But this is where it gets really, really cool. Because Kafka holds on to data for a period of time, it enables something that engineers have nicknamed time travel debugging. And yes, it's as cool as it sounds. So imagine some major issue happened at 3 a.m. Instead of just guessing what was going on, an engineer can use Kafka to literally replay the entire stream of metrics and events that led up to that incident. This lets them see the system's exact state as it was in the past, which just dramatically speeds up finding the root cause. It is an unbelievably powerful diagnostic tool. All right, for our fourth use case, let's talk about a huge problem, keeping everything in sync.
In any big company, you've got data living in all these different places. Databases over here, search indexes over there, caches. So how do you make sure they all have the most up-to-date information? Well, one of the best answers is a pattern called change data capture, or CDC, with Kafka right at the center, acting as the universal hub. And it's a beautifully simple flow. A change happens in your main database, an insert, an update, a delete. That change gets recorded in the database's log, and then it's streamed as an event into a Kafka topic. From there, a tool called Kafka Connect can deliver that change to any number of other systems, making sure everything stays perfectly in sync in almost perfect real time. And for our final use case, let's tackle one of the most stressful, high-stakes jobs in all of software engineering, migrating a critical system from old to new. This is where Kafka can be an absolute game changer, turning what could be a high-risk catastrophe into a calm, manageable process. You know, this is a huge shift from the old way of doing things, the Big Bang migration, where you basically just flip a switch and pray that nothing breaks. Instead, Kafka acts as your safety net. By putting it right between your old system and your new one, it works as a buffer. This lets you do a much more gradual migration, even running both systems in parallel to compare their outputs and make sure everything is consistent. And hey, if something does go wrong with the new system, no problem. You've got an easy way to roll back because the old one is still chugging along. It just fundamentally de-risks the entire scary process. So if there's one thing to take away from all this, it's that Kafka is so much more than just a simple message queue. I mean, from log analysis and AI to system monitoring and making migration safer, its incredible versatility makes it a truly foundational platform for pretty much any modern real-time data architecture. It's the flexible, scalable core that makes so many other amazing things possible. And really, that just leaves us with one final thought to chew on. We've seen how Kafka grew from a simple logging tool to the beast that it is today. So as this absolute tsunami of data continues to grow bigger and faster, you have to wonder, what new, completely unforeseen problems will powerful event streaming platforms like Kafka be called on to solve next?